by looking at the graphs, I want you to tell me the domain and range of a function. So first of all, this graph, the one on the left, I have a graph of a function. I didn't tell you what the function is. The graph starts at this point. You have to look from left to right. All right, so you go from left to right. The graph starts at x equals to -5. So this is a point on the graph, x equals to -5, y is equals to 3, and then you trace the graph. So it will just go up and down and then up, and then we stop at x equals to 8. All right. Now, for the domain, so by the way, what is domain? Domain is the place where x lives, right? So every time I say the word domain, then you have to think about x. Every time I say the word range, then you have to think about y. Again, domain is x, range is y. Okay, so now for the first problem, so when you have a function, so when you see a function without a graph, you are thinking, all right, the denominator cannot be equal to 0, right? So especially when you have a rational function, you are thinking, all right, the denominator cannot be equal to 0. If you have a square root, the function inside the square root must be greater than or equal to 0. If you have a cube root, the cube root of negative, positive, and 0, they are all defined, right? So on and so forth. But this case, I didn't give you a function. I gave you the graph. Now, for graphing problem, you will need to use a ruler. So the way I do it is I will just grab a long ruler. So maybe you can pause the video. So go get one right now and then we zoom to the video. So after you grab your rulers for the domain, I want you to listen. I want you to place the ruler on your paper vertically like this. This is your ruler, vertically like this. Why do I put the ruler right there? Because that place is where x starts. So can you do this for me? So on your paper, place your ruler vertically and then place where x starts. Make sure the ruler is vertical. Okay, so now you are holding it at your ruler, right? So your left hand is holding at your ruler. Now, can you go from left to right? So just push your ruler from left to right. So this is where x starts, right? So this is where x starts. And then eventually, your ruler should stop right here because that is where the x ends. All right? Now, from this place to this place, now tell me, x goes from where to where? X goes from -5 to +8, right? So -5, there is a solid point, past solid circle, 8, x equals to 8, there is an open circle. This is what I wrote. So for the domain, I will just write domain. And then x is between -5 and +8. So since we have a solid circle at -5, then we use an equal because x can be equal to -5. And then where there is an open circle right here at x equals to 8, then you don't use an equal. So that means when x is equals to 8, the function is undefined. And then how about for interval? So for interval, you use a square bracket, -5 to 8. This is x equals to -5 to x equals to 8. What about range? So for range, now pick up that ruler and place that horizontally. Where? Place that at the lowest possible y value, which is at that point. Do we agree that as x goes up and down, that point when y is equals to -6, that is the lowest y value in the entire graph, y equals to -6. And then, now, could you push the ruler all the way to the highest y value, which is right over here, when y is equals to 7. So we just went from -6 to 7. I should say y equals to -6 to y equals to 7. So that means for range, that is y is between -6, that is a solid dot. So we use an less than or equal to y, and then less than 7, because y cannot be equal to 7. I have an open circle. So that's how easy it is. For the range, should we use interval? I would not use an interval because I want to distinguish between this. So -6 to 7. If I put that, you might ask me, hey, is this for x or for y? But of course you can do a y and then y, right? So that tells me y equals to -6 all the way up to y equals to 7. But I usually don't write that because I don't want to confuse my students. So what I'm trying to say is, for the range, I will just use inequality, right? So let's move on to the orange graph. So for the orange graph, x goes from where to where? X goes from, put your ruler right here, from x equals to -4 and then all the way up to this place. So we will have to go from -4 all the way to positive infinity. So arrow means goes all the way up. So from -4 all the way to positive infinity. So let me erase those marks. I will just write domain. So this one is x greater than -4. No equal, because at -4 there is an open circle. And then for the interval, so that will be from -4, and then all the way to positive infinity. Never use a square bracket on infinity, because infinity, you don't know how big that is. And then how about range? So for range, you should use your ruler starting at the lowest y value, which is -5, and then where is the highest y value? Right here. That will just go all the way up. So for range, I will just write y is greater than or equal to -5. Y is greater than or equal to -5. From -5 all the way up, I use equal because at this point, y equals to -5, we have a solid circle. Solid circle means y can be equal to -5. It is okay to let y equals to -5. When y is equals to -5, x is equals to 3. And then for interval, I don't really prefer this way. You can do like -5 to positive infinity, or specify that this is a y, this is a y. Okay, so we won't mix that up with the x and the x. Okay, moving on to the next problem. So this time, where is the smallest x value? The smallest x value is like right over here, right? It's like -infinity. So as you push your ruler from left to right, you will just go all the way here. So from -infinity to positive infinity. Is this right? Can x be any real numbers? If you say yes, unfortunately, that is not the right answer. Look at the graph carefully. So there is a point where x cannot be. Where is that point? That point is when x is equals to +4. So when x is equals to +4, this is undefined. We have an open circle. So that means for domain, this is what we will have to do. X cannot be equal to, does that match the color? Or I picked the wrong one. Let's pick this. That is the right color. So when x is equals to +4, we have an open circle. So y is undefined. Now, you might be asking me, hey, did you say when x is equals to 4, y is undefined, but you have a -6? Are you asking me this? You just said that when x is equals to 4, y is undefined, but hold on. Look, you show me that point. When x is equals to -4, y is equals to -6. Why is this undefined? So the reason is this is called a discontinuity. So let me just give you a new vocabulary. When x equals to 4, y equals to -6, do you see there is an open circle? That is called a discontinuity. But you still know that y is equals to -6, so that is called a removable discontinuity. Again, removable discontinuity. Don't worry about what that is. You will study that in calculus. So at this point, when you look at this type of graph, just tell yourself that when x is equals to +4, y is undefined. So the domain is from -infinity to +4, and then from 4 to positive infinity. And then for the inequality, this is a x less than or equal to 4, and then comma x greater than 4. Why do I use equal? X less than 4, and then x greater than 4. And then for the range, where is the lowest y? The lowest y is when x is right here, right? So when x is right over here, which is a negative infinity, and then the highest y is at that point, but I didn't tell you what that point is, so let me just give you a number now. So how about that point? I'll just make up a number. How about 0.7? I'll just make up a number. All right, so that will be y is between, oh, I should not do this, because if you say this, look, that doesn't make any sense. That doesn't make any sense. I cannot put a negative infinity over there. So the correct way to write the inequality is just y less than or equal to 7. Since this is a solid point, I can use an equal. All right, so how about the red one? How about the red one? So x goes from this point and then to here, right? And then from here to positive infinity. So the way we write this is for the domain. We have x goes from positive 5 all the way to 1, and then we start at 1 when x is equals to 1, that goes all the way to positive infinity. And then what happens when x is equals to 1? This is the graph of a piecewise function. When x is equals to positive 1, we will be taking this point, y is equals to negative 2. So since we have two pieces, do you still remember the piecewise function? We will just cut that into two subdomains. So this is the domain for the first piece, this is the domain for the second piece. And then this is did I say negative? Did I say 5? Negative 5 to positive 1. So that would be negative 5 less than or equal to x less than 1, and then x greater than 1. Greater than or equal to 1. So that will be for the second piece. And then how about the range? The range will be, since, do you see this arrow? This arrow will just go all the way down to negative infinity. So the bottom line should be like right over here, negative infinity, right? So I will just go from negative infinity all the way to y equals to 4. So the way we write that is, for the range, let's write the word range. I will just say y is less than 4. So y is less than 4. Okay, so y is less than 4. How about between these 2 points? So between these 2 points, when y is between these 2 points, I have some x value over here. I will just take the first piece to find the y value. Okay, so that is the end of this video. If you like the way I explain domain and range, give me a thumbs up, a subscribe. I meet you all in the next video. Take care.